Yesterday, you guys started making a foldable on laws of exponents. Before we begin, I want to make sure you have it out. On the front, it says multiply, and hopefully you've already written on that same place product of powers. This is the name for the law of exponent that involves multiplication. On the one that says divide, I want to make sure you have written quotient of powers. This is the name for the law of exponents that deals with division. And finally, you have the one that says power of a power. On your foldable, it says power to power, but cross off the to and write of a. So these are the names for the laws of exponents that you need to learn today. You're going to have some practice on it, and I want to give you a heads up that on Friday there's going to be a quiz on these laws of exponents, negative exponents, and the basics of exponents like simplifying and multiplying them out, which we did last week. I will post on Edline the link to this YouTube video so you can use it as a resource. But you need to be studying and come see me at MAP tomorrow or lunch or after school if you need some extra help. There's also plenty of videos on YouTube and on khanacademy.org. Let me write that for you. khanacademy.org. Sorry, my handwriting is not great on this, but khanacademy.org. So, the factors of a power, such as 7 to the 4th, can be grouped in different ways. I want you to make sure you're watching this video so you can see the red laser pointer. I'm pointing right now to 7 times 7 times 7 times 7. This is 7 to the 4th. The base is 7, the exponent's 4, and that means that we're multiplying the base by itself 4 times. We know that this equals 7 to the 4th. But what happens if I look at this in different groups? So I still have my 4 7s, but now I'm going to put the first 3 together and leave the last one by itself. This 7 times 7 times 7 also represents in exponents 7 to the 3rd. And this 7 right here represents 7 to the 1st. We still have a total of 7 times 7 times 7 times 7, which we also know equals 7 to the 4th. Ignore these blue boxes. They were for the flip chart, and I can't get rid of them. So we see that we have 7 to the 3rd times 7 to the 1st, which is 7 to the 4th. The other way we can do this is by grouping them in twos. 7 times 7 is 7 squared, and 7 times 7 is 7 squared. But again, we still have 4 7s, and together we know that that equals 7 to the 4th. Pause this video right now, and I want you to think about different ways, or what you notice, the relationship. Like, what do you notice between these that we're multiplying together, the different groupings, and the final answer? Do you notice a relationship between the exponents in each product? Pause the video now. Okay, hopefully you saw that 7 to the 3rd times 7 to the 1st and 7 to the 2nd times 7 to the 2nd both equal 7 to the 4th. But also, we can see that this power of 3 and this power of 1, 3 plus 1 equals our power of 4. Down here we have 2 and 2, and 2 plus 2 also equals our power of 4. This is going to lead us into our first law of exponents. Our first law of exponents is the product of powers, which is multiply. This is saying that when I multiply one power, remember a power is a base with its exponent, so when I multiply one power times another, and they have the same base, we can keep the base and add the exponents. So let's write this. When two powers with the same base, this is very important. If they don't have the same base, you can't do it. So when two powers with the same base are multiplied, you keep the base and add the exponents. So the rule is a to the m times a to the n equals a to the m plus n. All this is saying is that when you have the same base, you can add the exponents. Please pause the video and make sure you've written both of these down on your foldable. Now, on your sheet of paper, I want you to try A and I want you to try B. Notice that they have the same base, so this product of powers rule applies. You can pause the video now and try these two problems. All right, hopefully you've solved these, and I want to see two steps. There's the step that's given, and the first step I want to see for now is you keeping the base and adding the exponents. So 6 to the 6 plus 3 power, and then the final step is your final answer, which is 6 to the 9th power. So until you get the hang of this, I want to see this step and I want to see this step. For n to the 5th times n to the 7th, we have n to the 5 plus 7 power, and that equals n to the 12th. Did you get these right? Hopefully you did. Let's try some more. Try these two problems, C and D. Be careful with D. And I want you to show me your two steps. Pause the video now. All right, for C, we have 2 to the 5th times 2. They have the same base, but what's missing with 2? Hopefully you're saying to yourself right now, an exponent. An exponent of what? Hopefully you're saying 1. So 2 to the 1st is the same thing as 2. With that written there, we can now see that we have 2 to the 5 plus 1 power, which equals 2 to the 6th. Looking at D, we have to be very, very careful. I told you with the last rule, they have to have the same bases. If they don't have the same bases, you cannot multiply these together. Don't try to multiply 25 times 24 to the 4th power. This is your simplified answer. Now, I think I spelled that wrong, sorry. But anyways, if you have 25 to the 4th and you find out what that answer is, it's going to be some really large number. And then you find out what 24 to the 4th is, and it's some really large number. Then you multiply those together and you get a really large number. That's the only way you can solve it. But you can't rewrite it using exponents because they do not have the same base. Now I want you to notice what occurs when you divide powers with the same base. So far we've learned 5 to the 5th in something that's called expanded form. I never used that vocabulary with you, but expanded form is just writing it out in multiplication. So 5 to the 5th is 5 times 5 times 5 times 5 times 5. 5 fives because the base is 5 and the exponent is 5. On the denominator, how many 5s will we have? Hopefully you're saying 3. So we have 5 times 5 times 5. When we divide and we have the same number on the top in the numerator as we do in the denominator, they can cancel out because 5 divided by 5 is 1. So every time you have a 5 or any number in the numerator and the same number in the denominator, you can cancel it out. So we can cancel out another set of 5s and we can cancel out a third set of 5s. This leaves us with 5 times 5, which is also 5 to the second power. I want you to try this second problem down here, 2 to the 8th divided by 2 to the 4th, on your own, written in this expanded form, and then canceling out the numbers in the numerator and the denominator that can cancel out, and seeing if you can get an answer like this. Pause the video now to try it. So now we have 2 times 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 2. We should have 8 2's, because that's 2 to the 8th, divided by 4 2's, which is 2 to the 4th. When they cancel out, we see that we have 4 2's canceled out on top and 4 2's cancel out on the bottom. And we are left with 2 times 2 times 2 times 2, which is also 2 to the 4th. Now I want you to notice when we divide and we get 5 to the 5th divided by 5 to the 3rds, we're left with 5 to the 2nd. And 2 to the 8th divided by 2 to the 4th, we're left with 2 to the 4th. How do you think we can make a rule to get from this division to this final answer without writing out all of this? You can pause the video and discuss as a class. Hopefully you might have noticed that the exponents of 5 and 3, when subtracted together, give you this exponent of 2. Or 8 minus 4 gives you an exponent of 4. This is going to be our next law of exponents. Our next law of exponents is the division one, which is the quotient of powers. This means when you are dividing by powers. So our rule that I want to make sure you write down in your foldable is a to the m divided by a to the m. So notice again, they have to have the same base. So when you divide two powers that have the same base, you can subtract their exponents. So in words, when you divide two powers that have the same base, and make sure they have the same base. You can't do this otherwise. When you divide two powers that have the same base, you can keep the base and subtract the exponents. So make sure that you have this written down on your foldable. And then I want you to look at these two problems down here and try them on your own. Pause the video and make sure everybody's written this down, and then try these two problems. Okay. Now that you have this written down, notice that 7 to the 5th divided by 7 to the 4th has the same base. So we're going to keep the base and subtract the exponents. Again, I want to see this work right now until you get the hang of this. I'm going to keep the base, and 5 minus 4 is 1, so you can either have it as 7 to the 1st, or you can leave your answer as 7. For x to the 13th divided by x to the 9th, we keep the base, which is x, and take 13 minus 9 as the exponent. This gives us x to the 4th power. I know x is a variable, but it's still the same way whether it's a number or a letter. I want you to try these two problems on your own now. They're the same thing. You're using the quotient of powers rule. Pause the video and give everybody a chance to work. All right, for this first one, we have 9 to the 9th divided by 9 to the 3rd. We keep the base and subtract the exponents. And we have 9 to the 6th power. For this problem, we have e to the 10 minus 5 power, which equals e to the 5th. Did you get these right? I sure hope so. All right, now we're going to move on to our last law of exponents. So I want to know how to solve these two problems. Here I have a power, 2 to the 3rd, to another power. So this is called power of a power. But let's take it back a step before we worry about what the rule is and look at how would I solve 2 to the 3rd to the 2nd power. Well, if this was just x to the 2nd power, we could write this out as x times x because that's what it means to be to an exponent of 2. The base is multiplied by itself 2 times. Well, here my base is 2 to the 3rd. And I'm multiplying it by itself 2 times. So I have 2 to the 3rd times 2 to the 3rd. We just learned with our product of powers that when they have the same base and you're multiplying, you keep the base and add the exponents, and this will give us 2 to the 6th. For the second problem, we have 3 to the 4th times 3 to the 4th times 3 to the 4th times 3 to the 4th. Because it is our base, which is 3 to the 4th, multiplied by itself 4 times for this exponent. Well, this gives us 3 to the 4 plus 4 plus 4 plus 4. And that equals 3 to the 16th. So what I want you to look at is, how do you think we can go from here to here? Or here to here? I want you to look, pause the video, and discuss as a class ideas about how we can go from 2 to the 3rd squared to 2 to the 6th, and 3 to the 4th to the 4th to 3 to the 16th. All right, hopefully somebody noticed that when I have this, if I multiply 3 times 2, I can get my exponent of 6. Or when I multiply 4 times 4, I can get my exponent of 16. This is going to lead us into our final law of exponents, which is the power of a power law. Our power of powers says that when we have a power taken to another power, we can multiply the two exponents together. So we keep the base and multiply the exponents together. If we want to write that in words, we can say that when taking a power to another power, make sure you write this in your foldable, we keep the base and multiply the exponents. So this is our power of a power, and this is our rule. A to the m to the nth power equals a to the m times n power. What I want you to do is make sure that this is all written down in your foldable, and then I want you to try these two problems. So pause the video, give everybody a chance to write, and then solve A and B. So with our rule that we keep the base and multiply the exponents, 5 to the 4th to the 2nd power is the same thing as 5 to the 4 times 2 power, which then multiplies to 4 times 2 is 8, so 5 to the 8th power. For 6 to the 7 to the 9th power, we have 6 to the 7 times 9 power, which is the same thing as 6 to the 63rd power. So this is our power of a power rule. We multiply our exponents and keep the base. So for this last practice, I want you to write the exponent as 1 power, and I want you to use the power of powers laws to solve each of these. Please pause the video, give everybody a chance to solve, and then come back. All right, so 5 to the 7 times 2, so 5 to the 7th to the 2nd power is 5 to the 7 times 2, which is 5 to the 14th. And then we have x to the 3rd to the 5th power, keep the base. We have 3 times 5, and this gives us x to the 15th. Hopefully you got these right, and this concludes our laws of exponents. What I would like you to do is you're now going to work on the classwork, which is a Laws of Exponents worksheet. On the front is another set of notes, just reviewing everything you learned today, and on the back are the problems that I need you to do. Remember that you are using your multiplication and division. We're using our product of powers and quotient of power rules to solve these. And after you've finished, there on the flip chart that Mr. Washington has, there will be the answers. So I want you to check over this before the end of class and come back with questions tomorrow. On your homework, you're going to have another worksheet to practice this stuff. And I just want to make sure you understand that because it's copied, some of the problems look like they're adding, but I promise you they are all division. So please don't sit there on Thursday when you're showing me your homework and say you thought they were adding, because I'm going to refer you back to this video. Again, I will post this video on Edline, so you have a link to it. And please come in tomorrow with questions if you have them. Remember, Miss Mitchell is also there to help. I look forward to seeing you all tomorrow. Have a good day.